That's the name we chose for the first SWIB in 2009, and this is what the SWIB synonym stands for, translated to English, Semantic Web in libraries. Semantic Web, this label is not used anymore. Instead, you heard terms like linked open data, or since recently, linked open usable data. But the vision of the Semantic Web is still manifest in work done in libraries, archives, museums, as well as in talks at SWIB and similar conferences. And this vision is to improve the web by publishing and linking not only web pages, but more granular information bits, single statements, and to publish information intended for humans in a way that it can also be consumed by machines. The vision of the Semantic Web was introduced to a wider audience in a seminal article itself titled The Semantic Web. The paper enthusiastically presented the prospect of the Semantic Web to, quote, unleash a revolution of new possibilities. 17 years later, we can say that a lot of things have happened around the Semantic Web, but also that a lot of high hopes haven't been fulfilled. One of the people who originally presented the idea of the Semantic Web is James Hendler, who co-authored the Semantic Web paper with Tim Berners-Lee and Ora Lassila. We are feeling very honored that Jim accepted the invitation to hold a keynote at this special occasion of SWIB number 10. Today, Jim is located at the United States' oldest technological university, Rensselaer Polytechnic Institute. There he is director of the Institute for Data Exploration and Applications, as well as Tetherless World Professor of Computer, Web, and Cognitive Sciences. He also holds numerous other positions and fellowships. Just go to his Wikipedia page to see the details. I won't enumerate them all here. Jim has authored countless books, technical papers, and articles in the areas of semantic web, artificial intelligence, processing. I'm looking forward to him taking stock after nearly 20 years of semantic web efforts. A big welcome to Jim.
So hello, everybody. Are connected? No. That's yeah. We won't do the slides. That's all. If that works. Nope. Hold on. Okay. Good. Okay, so, oops, that won't help me. Go back. Just use the space. Just want to go back. Sure. Okay, sorry. So wow, so conference about 10 years old. I was realizing as I was putting this talk together that it's been almost 20 years since I first encountered the term semantic web. It was in work I was doing for a number of years. We had been working on embedding richer metadata on the web, and I started working with Tim Berners-Lee, who was using the term semantic web for some of the same ideas, and that's what led to the publication. Now, recently when I give talks, I find I often have to start by a quick digression, which is the term that a lot of people have heard more than semantic web these days is the term knowledge graph, which arguably was introduced in 2012 by Google, although to be fair, what we really should say is in 2012, Google coined the phrase knowledge graph to talk about what other people had been doing for a very long time at that point. So Some people use the term knowledge graph really to refer to linking data, putting things together. But the original proposal for the World Wide Web by Tim Berners-Lee, this is a famous slide, you can find it, was back in 1989. It's not 23 years, it's 13 years, but I've been doing this a long time. But this is the actual cover of the document, that famous document. Tim submitted this document at CERN. His boss called said vague but exciting on it. That's become a famous phrase nowadays. And luckily, about a year later, he was actually allowed to start working on the system that had the odd name World Wide Web. It was all one word when he started. It got separated into 3 Ws a little later. But you can see it was very much this notion of a lot of terminologies where the terms were linked to each other by named links. So the knowledge graph idea, the semantic web idea of this graph of information about the stuff on the web has been around since the very beginning of the view of the web. In fact, in his Turing Award talk last year, you can find it online if you just use your favorite search engine and look for Tim Berners-Lee Turing Award talk video. He reprised these slides, which were from a talk he gave in 1994 at the first World Wide Web conference, I believe it was, where he talked about, explicitly, the name of the slide was The Need for Semantics in the Web. And he said that the way people think traditionally about hypertext is like the first slide, just these pieces of documents that are just linked together. But that he liked to think of it a different way, which was that those links represented the real objects and imaginary concepts and the relations between them. And he used the example of a house, a document about who owns the house, and the ownership relationship. So from the very beginning, his idea of the web included this notion that the documents on the web describe real things in the world, and that to be able to really work correctly with the web, and at that point the web of documents, and by the time Tim and I started working together about 10 years later, we were really talking about the web of data as well as the web of documents, needed these concepts of things linked together. So when we wrote the article in 2001, it was this idea, right? And what's motivated today's talk is the fact that we've been approached about sort of doing a new version of the article, and we keep deciding we're going to do it and then getting too busy to actually do it. So I'm trying to think through I'm giving a series of talks related to this, hoping that eventually what will come out of that is enough ideas in my head of exactly what we need. So I will hit you up at the end of this talk for a couple things. I want you to send some papers to a journal, and I want you to think about what the semantic web is missing and what we need to add. But to start with, let's look at what we had. So I went to the US funding agency, DARPA, which funds most of the computer science work in the US, the Defense Advanced Research Projects Agency, and I started the project that became called the DARPA Agent Markup Language, but very rapidly started working with Tim on that project, and so it informally became known as the Semantic Web Project, and later people pretty much have forgotten DAML and just call it Semantic Web. And from that, RDF was already coming along, but a lot of the formalization happened in part because of this, and then the language OWL came about. Through this, DAML was a predecessor, and I'm not going to go into all that history. The very first briefing I gave about this to my boss at DARPA, they said we had to have a schedule. And so this was my notional schedule in 2001, that we were throwing a snowball on a hill full of snow, and that eventually it would become an avalanche. And let me just say, he wasn't quite as encouraging as vague but exciting, but he let me have the money anyway, and we're still here. But let me just use an example so where are we today? What is working, what isn't working, what do we need to do about it? So to start with, a lot has happened on the semantic web, and I can go through a lot of different things. I'm just going to use one example, which is semantic search. So around 2010, people started talking about if we had this then, and search was just starting to really generate money by then, could that really be used to enhance search, right? Entity resolution in particular. And a bunch of companies started up very early on. You may have not have heard of very many of these. Some of them went in different directions. For example, the company called Siri actually moved primarily into voice interface, and then voice interface for search, and is now sort of, if any of you have iPhones, you know what Siri is. The one in the middle there, PowerSet, was bought by a company called Microsoft and renamed Bing. So that one's been pretty successful. They merged with the Bing group. It wasn't all Bing, but it was really to bring semantics to Bing. Freebase is on there somewhere, I think. Yeah, Freebase was bought by, eventually by Google, became really the base of the knowledge graph, and is also the base of what then became Wikidata, which I know many of you have heard of and played with. And some of the others up there are still around. Some of them have gone away. DuckDuckGo uses some of the technologies from these things. So this notion of using search, using semantics to enhance search was a very real idea, a lot of competition. Within a few years, though, most of that competition had gone away. By 2012, and now this was a slide made in 2015, I think, you really had only one real semantic search engine, and it's really Google, although again, it's also in Bing, Baidu, and all the others. But it was this idea that when you search for an entity, if you could find the entity, could actually resolve what entity it is. So here's somebody searching on my name. Google has decided it's looking for the person with that name. And over in that box on the side, all of that is just the display of the information that they feel is most relevant to that information type. So if it's a person, you get things about the person, about what the person does. So for me, you get some books I've written, you get some of the people done. If I was more famous, you would get things. So if we do Tom Cruise up there, you get a lot more information about the movies they've been in and things like that. I think I have that example later. But there was an interesting evolution of how this stuff came about. And I find a really fun way to do this is just to look at what Google said from about 2009 to about 2012 as this stuff was breaking. So in 2009, Google wrote, some people from Google, Alan Halevi, who was the head of data there, Peter Norvig, who at that point was the director of search quality, is now their research director, and Fernando Pereira, wrote an article called The Unreasonable Effectiveness of Data. In fact, half the slides I'm going to use, I'll switch into those for the second half of my talk, are actually from a talk I give called The Unreasonable Effectiveness of Metadata. But they said, for many tasks, words and word combinations provide all the reputational machinery we need to learn from text. So basically what they were saying is, we really don't need any stupid semantics, right? We got these words co-occur, people search for words, we find the other words on the page, those co-occurrence data, right, are all we really need. And that's still going on today. It's moved into stuff being done with word embeddings, deep learning, things like that. But it's not all or only what the search mechanism is about. But so their argument at the time was the data itself is all we need, right? We just are finding correlations in the data. By 2012, Peter Norvig gave a talk. Do I have the, no. So for some reason, I have pull quotes that are supposed to come up. My animations, I guess, were not in this version. So he said, at Google, we try to connect our customers with the information they want. He goes on and on. He says, if there's information, so we've heard a lot of talk about the semantic web, and that is coming along, but it's not quite here yet, in that there's some markup on the web that's explicit declaration, an object of this type related to that type, but most of the information on the web is not of that type, and we're still learning. So by 2012, Google was sort of saying, well, there is this semantic markup out there, and it is useful to us where we can find it, but it's not very useful. In fact, a little while before that, at a meeting, someone else from Google had said, you know, we will never see this stuff on a noticeable percentage of the Google crawl, right? 2013, Guha, who was at Google at the time, an interesting character in the history of the semantic web, and if I had several more hours, we could just talk about Guha. Brilliant guy. But Guha has been very involved with the semantic web from the very beginning, was very involved in the RDF effort, but really felt that the most important thing was usability, not in the sense of making the semantics interesting or usable, but how it could be embedded. And by 2013, since most websites were all auto-generating, he came up with the idea that and he'd been saying for a while that until we could get webmasters to do this themselves, and particularly the generation program, so when you created a bunch of web pages from forms, if those forms could have embedded metadata, you'd get a lot more stuff happening. So they came up with something called schema.org. I hope most of you have heard of schema.org because I don't have time today to go into it, but schema.org basically lets you embed some information around your search, and it improves search results. So they actually came up with not just a way of representing things. So it was a set of about, it's up to I think 240, 250 classes, very, very tied to web commerce and search. So for example, the religion category has 6 religions. The 5 most searched ones and one called Other. Doesn't really represent religion in the world very well, but it turns out to be just fine for representing most of the searches you need about religion, things like that. You know, very simple stuff on people, et cetera, et cetera. So this stuff came along very well. In fact, by 2016, when Peter Norvig gave a talk at the World Wide Web Conference, Peter said Google finds embedded metadata now on greater than 40% of its crawl. So we went in 4 years from you're never going to actually see this stuff in any noticeable percentage to it's approaching the point where half the web has this stuff on it. Now, as a note of caution, I note that the web has a very long tail and that originally they were quoting like 25%. At that point, it was just a few of the biggest search sites, Amazon, or most search sites, Amazon, Barnes & Nobles, Best Buy, things like that. Now it's far, far greater. To hit 40%, you have to come down more of that tail, and it continues to grow. So again, this is, we won't talk about why moose is in here. I used to give this talk, I always had a moose puppet, and if you search on my talks and mooses, you'll see moose shows up a lot. I had a moose at a conference in Canada, and Tim Berners-Lee used it in his talk, and then Peter Norvig used it in his talk. So I finally got jealous because the moose was so much more famous than I was. But basically, and Google has created what it calls the knowledge vault. They have an API that gives you some of it. In fact, Wikidata was taken in part to be a way of exposing some of that information without exposing all of that information. So they've built this big knowledge graph, okay? That same idea has been taken by other search engines. So there's Baidu's Tom Cruise page. I just put Baidu, yeah. You'll see the same thing on Bing. You'll see the same thing. So also turns out other companies, Amazon, many of the other large companies, Apple. So a lot of the companies that do things with knowledge are using these linked graphs of knowledge as an important component in how they interact. So the driving feature of a lot of this stuff, so why did we see this 2012, I'm missing some stuff, okay, so when I left home yesterday, Sunday, my travel computer and my regular computer were next to each other. And I grabbed my regular computer rather than my travel computer, which is the one that had this talk on it. Thanks to the miracles of modern science, I called my wife at home last night and said, open my computer, this is the name of the file, upload it to the cloud, and then I downloaded it from the cloud, and here it is. However, what I'm realizing now is some of the changes I had put in aren't there. Hopefully the rest of it is right, otherwise I'll have to go get something different. But anyway, but I also had some slides on some other companies, Facebook using this stuff heavily in what's called the Open Graph Protocol. In fact, in about 2014, a turtle interface was built during the summer by an intern who's actually now working at Google, to make it so that anything in the open graph, the things that are exposed externally to developers, was available in Turtle. And so the semantic web notation. And he was given permission to do it under two conditions. One is that he didn't break anything, and two is that they would turn it off if no one was using it, right? He eventually came back, he said he had to change, he actually had to go to them and said, I need one change, and it's obscure and I won't go into it, and they decided this was worth it to make that one change, so they did. And then the other thing is, it's now, actually it was about 2013, I guess, so it's now 5 years later, it's still there. So it's clearly being used. And in fact, some companies that I've been involved with just peripherally have used that data. They've extended it. So that's still there. So clearly this stuff we call the semantic web, the knowledge graph, whatever we call it, is being very heavily used in industry. And what drove the change was really the maturation of linked data technologies. So DBpedia drove a lot of this change as people started seeing that you really could make this stuff happen very quickly without having to have careful ontology engineering. So all the papers on ontology quality and ontology metrics and ontology this and ontology that, that's still an active area of research. But what sort of happened over in the knowledge graph side is they said, to hell with all that. The more links you have between the more things, the better the math gets, and that's good enough. So it was almost the same thing as saying, all we need is the word relations. Now it's all we need is the link relations. But also you had some graph database standards, Sparkle endpoints. Now there's something called GraphQL, which is sort of a simpler version. JSON-LD lets you get to some interactions without getting into Sparkle. Sparkle itself has used in a lot of different places. A lot of database engines now will let you actually use a Sparkle interface to SQL. So again, lots of technology stack, right? I've reached the point where I really enjoyed it. I went to one of the workshops yesterday, and I'm very happy to say that I understood almost nothing, right? It's taken me 20 years to get to the point where this technology is so far beyond me that the only way I can program semantic web things anymore is with a graduate student. So these things were happening, and lightweight knowledge, what's called a little semantics, that's another whole theme. If you just search on the phrase, a little semantics goes a long way. You can find a web page I used to maintain on it. So what's driving the main research in industry is what's called entity search, primarily for advertising. So again, if you look at searches on the web, and most of the published results on this come from Peter Mika, who was at Yahoo when he was doing this and published with their permission. So some of the numbers that get cited or some of the things that get talked about, it's hard to find Google's equivalents or Bing's equivalent, but he had these wonderful examples. But in 2016, at a talk at the World Wide Web Conference, the one with the moose, Peter Norvig used this slide where he talked about, what is really driving a lot of their research today is how do they get from the stuff they know about, stuff they're finding on pages, and link them together. So he called that practical reconciliation. There was some talk about human in the loop. So a lot of the driving research at the moment is how to fix some of this stuff that goes wrong in these things. So Here's an example from, so these examples are from Yahoo's 2014 search that Peter Mika was willing to share. There are some famous examples of Google errors out there that you can find if you use a search engine and search on Google discovers world's oldest man, you'll find another example of this. But, so this is the rapper Ice Cube, and you can see the metadata about him that they have in the knowledge graph is pretty good, how tall he is, when he was born, his parents, spouse, children. But the description of an ice cube is a small, roughly cube-shaped piece of frozen water used to cool beverages really doesn't go along too well, right? So something's wrong in a system that can confuse those things, and there's a technical reason why that happened more than just the word ice cube, although it tends to be because of the relationship, because it was a phrase, not a single name. So it was determined to be a product, not a person, and that's why it found the product name to put with the person information. My favorite example, actually, is the next one. And when I teach a course on this stuff, the next slide, there's one hour lecture I give where this is the only slide I use. So I'm going to try not to talk about it too much today. But this is what came up from Michelangelo. You know, again, describes an artist, when he was born, when he died, parents, all that sort of stuff, and has a very nice picture of him. And you can see it's really not a great picture of the artist Michelangelo. Now, part of what makes this so interesting is from the point of view of the computer, this is a great picture of Michelangelo, right? So first of all, it has associated Michelangelo with being a Renaissance artist, right? Some other Renaissance artists are Donatello, Raphael, Leonardo. So those four tend to show up together quite a lot, right? In fact, on the web, they show up far more often than the museum quality data that would describe a bunch of artists. The Teenage Mutant Ninja Turtles were far more popular. Okay, so associative learning, which is what really powers a lot of the knowledge graph, finds a very, very strong association between the concepts, these photos, things like that. And there's really no metadata describing this thing. There's really nothing in here that says this is a picture of the Ninja Turtle. The picture sits separately on the pages. So the system is trying to determine what the picture is a picture of, and it's just saying this is a picture of something called a Michelangelo, and Michelangelo is a human, et cetera, et cetera. So I'm sorry, here's Facebook's Open Graph. Here's that page when I was looking for, here's a lot of things. So around 2012, 2013, lots and lots of use of Semantic Web came about. But in our original vision, we actually had some different stuff that really didn't come across. So one of the reasons I suspect many of you are here today is that also starting in the mid-2000s, starting to really take off around 2010, was the use of Semantic Web for annotating the information in libraries and museums, right? Some new formats, particularly something called SCOS came along. A lot of tools were starting to be used. So people who were trying to do curation of large collections were discovering that these could be really useful tools, that the ability to actually keep some of the metadata around. So this part of the vision was that we would have all of these things linked together, very knowledge graphy. BBC was also doing a lot of this. There were a lot of demos written around the 2012 Olympics. Used to be you could find RDF version of just about everything at the BBC. That's now changed. There was this big flurry, you know, Semantic Web dies because BBC turned off the RDF feed. In fact, what BBC did is they internalized and made it easier to find this stuff in different formats and things like that. So the rest of the original vision, right? So we started to see this stuff taking off. We started to see a lot of use of this. We started to see a lot of description. But so in some sense, I feel like I could just declare victory and go home, right? At my first meeting of this stuff, people said, this stuff will never even show up on the web. And now Google's saying, you know, it's on 40, 50%, and it's all over the place, and it's being used in college libraries all over the world are using it. I was recently gave a talk at the Chinese conference on knowledge graph and semantic web. They had about 800 people for the local Chinese conference, had about 30 sponsors. So it's huge there, things like that. So lots and lots of this linked data, knowledge graph stuff is out there in the world. There was a panel at the recent ISWIC with people from about half a dozen companies talking about how they use knowledge graph technology. So basically, there is a piece of this, which is that linked data and knowledge graphs without semantics are really too weak for many applications. So problem number one is, how do we start getting a little bit of that semantic stuff back in there? And there's a fair amount of that research going on. Sometimes you hear the term linked data semantics or knowledge graph inferencing. It's actually really interesting when I go to a conference now and people are talking about, the linked data vision was a great vision, but it was missing semantics, right? And I occasionally say, well, when we called it the semantic web, we thought that might imply that semantics were involved. But actually, and what's really motivating us to think about writing the article again is there's a whole part of the original vision that's still extremely challenging, right? And that's the interoperability issue, right? So it was never really just about getting those links onto the web and the labels on the links. It was getting people to link to each other's things, people to find each other's things, and for those links to become more descriptive, right? For the links to actually help you understand why two things were linked together or what it meant for two things to be together. That's why it's not just a single term link. The links have meanings and you can dereference and all those things, okay? So what I'm going to do now is shift over to sort of the other half of the talk, which is really more about what's missing, why metadata, and why much of our original vision was driven by sort of this metadata thinking. And really to challenge a little bit that some of that, again, you go to a lot of the current semantic web conferences, things like that, you hear a lot about linked open data, things like that. I'm a big fan, don't get me wrong, right? But you're missing some of the metadata aspects, what it was about. So when I give talks, so I also, I had something called the Institute for Data Exploration and Applications. So in that role, I was, our university started one of the first big data institutes at any university in the US. We're not one of the best known, but we are the oldest. That tends to be the theme at Rensselaer. We're always the oldest, we're the oldest technical university in the US, but in a few years, about 15 years after we started, Boston decided they wanted one too. And created this thing called the Massachusetts Institute of Technology, which a lot more people have heard of. Some other things happened here too, but anyway. But when I started talking about this, I liked using this acronym. I call it Dive into Data, right? Partly because I found that wonderful picture. But what really, a lot of the notions behind the original semantic web, and I'm going to mostly focus on the top two today, although I'll play with that last one also a little bit, is discovering, integrating, and then later validating, explaining what you find. So again, it's not enough to just have a bunch of your own linked data sitting somewhere, right? The purpose of that should be so that other people can know what data you have and pull it up. So it's nice that you have a collection in your library, museum, TV show, TV station, on and on and on. We keep finding new things. Health, huge amount of this stuff in health. But again, I have the scientific database, and what I'm using this stuff for is organizing my users' interaction with my database. And then at some point I say, SQL was actually pretty good. This little bit of extra graph stuff is good, so now I don't really need that complex Sparkle stuff, because all that distributed nature of it I can do with a little bit of light linking, and I don't really need that. Okay. When you're really trying to do complex querying over multiple collections to find what they have, that's where you need some of that complexity. Even more when you try to integrate. Okay, so I have found you have some concepts, listing some of your collection. I have the stuff listing my collection. I'd like to find the ones that are the same so users can trace information from one place to another, things like that. That's the integration. I'll talk briefly about validate. In fact, I have the wrong, if this is the talk I think it is, I have exactly the wrong slide in validate. But validate was part of how do we get around that problem with the Michelangelo picture. And explain is something we're playing with now. I'm starting to use the term explore sometimes. It's how do we also make it not only so that the data can be found and integrated, but used in interesting ways. So basically, how do we find the data sets outside of our own organizations? How do we link these relationships using meaningful labels? How do we reconcile what's in one with another? How do we provide the input so that these things can be used by other systems to validate data, to make things better, et cetera? And then you can see I should switch to Explore here, so this is my more recent slide. Developing some approaches to turn data into action. So let me go through those briefly. So this is the famous linked open data cloud. I forget which year's version this was. The middle of it is DBpedia, so that's that circle in the middle. And since they were the ones who created this, the original linked open data, sort of it was at the middle and it's never moved away. The size of the largest circle is the size of DBpedia at that time. It's never actually grown. So many of these circles, actually, if you built it to scale now, some of the stuff in government data and some of the stuff down in health data in particular would be much, much larger than the others. So there's been a few communities that have used it very, very heavily. But the problem is when you're talking about data elements and you're just linking data between things, you're losing a very important concept. Okay, so here's some database, and somebody has said, well, you know, going across I have people, and coming down I have dates. So again, it's nice to know these things are people and these things are dates, but what dates are they? What people are they? So it requires a context. So I want to say that this was the data set that refers to the people born in the year 1976, perhaps, right? So now those dates are actually not random dates, right? They're dates that the people with those names were being born in that year, right? On the other hand, if this was the 1976 cancer mortality dates, right, that would be a very different meaning, right? That's the day those people ceased to be coming into existence or in existence. So those would be when people were dying of cancer. And again, that's too simple an example because I might have very rich things in here. But I need something that tells you which things in that database are linked to which other things. So in a sense, what's wrong with the linked open data concept without the metadata, right, is that what you're saying is, and in fact, it's really a problem with the linked open data cloud, and I've had many conversations with this at a very geek level with a lot of my colleagues in it, is, so for two things to be considered linked in the linked open data cloud, they must either be using the same URL or the same, an OWL same as, right? So this Berlin is the same as that Berlin, right? That's a famous example because it's very, very ambiguous in geodata and it's very ambiguous in DBpedia. So if I want to know I'm talking about the city with the same place versus a different city in a different country, et cetera, and then there's people and things like that. And again, that's that confusion issue. But there's a different issue, right? So a lot of us have been for a long time, when we were doing government open data, we were doing this. We would take what was in a big database, realize it with some slightly more meaningful names, put it into a triple store somewhere and make it available through Sparkle. And of course, two problems with that. One is you tended to lose efficiency because there were lots of great tools that have been developed over many years for that data that can be in nice, neat tabular form to be rapidly accessed, et cetera. So what I really wanted to be doing is describing the data. The second thing is that we didn't consider linked. So here's a set of, in the early days, here's something that has FOF data, friend of a friend, and here's something else with FOF data, right? Just because they're both using FOF, they would not be considered linked in the linked open data cloud. But in point of fact, if you're using Phelps correctly as your metadata, then some of what's in there are things that can be inferred to be equivalent, right? Inverse functional links and all these nastily named things, but basically says, you know, two people with the same identifier of this type are really the same person. Email address was useful on the web, right? So granted, multiple people may share an email address, but in general, from the web's, a web application's point of view, the unique identifier that's often used is an email address. So if I say this thing has these blogs that were authored by this person who has this email address, and these blogs were authored by this person as these email address, then I could link them through the fact that that email address was considered to be a unique identifier. So a lot of the issues that had to do with really understanding the linking happen at that metadata level, the fact that you're using the same vocabulary, right? And that sort of got lost from the linked open data early on, and is something we really need to bring back. The notion that using the same terms and terminologies is already a way of helping people do a lot of the discovering of what's out there, right? If things are represented using SCOS and different things, I may not know that these are the same, that these are synonyms for, in different languages, say, for something. But I still know a lot about their relationships to other words and things, so even if I have a few known relationships, I can infer many others. Okay, so that was discovering is if we can put these things, if we can label them better, if we take more attention to the metadata, that's helping it. But the one that I think is most important and has really been what's driving a lot of the conversations I hear now with people who are wanting to use linked data is the integration issue, right? How do I take what I find at one place in linked data and what I find in another place and put it together where I don't necessarily have exactly the same stuff? So if we're all using DBpedia and we're all consistently using it correctly, which is already hard, then in theory we might say, okay, we're pointing at the same thing, we're talking about the same thing, that's great. But a lot of these things extend these other representations, things like that. So right now, the way most of this is happening is data is converted into RDF, and I said sparkled here, but of course nowadays, again, other tools. Data is converted from a database into Sparkle on demand. So there's a lot of tools out there now where you have your structured data, you have a tool that lets you build a mapping, and then you get a Sparkle interface at this end and a SQL interface at that end, so you can do the fast data operations on one side, pull it back out as a linked data table that can then be used on the Semantic Web side. The OWL same as is really hard to use in its full technical correctness. So you can still find papers at International Semantic Web Conference talking about how everybody has to stop misusing OWL same as and start using it correctly. Or some of us say we should really stop claiming OWL same as has the semantics from the original model theory and actually start supporting what people do with it, which means these are designating the same object in the real world. They're not logically, equivalently, exactly the same thing, because by definition, if they're asserted in different places, they can't be OWL same as, right? Long conversation. But having that mapping is easy, but really using it correctly is tricky. And then SCOS provides sort of ontology level things. These are the same, these are similar, these are near concepts. And that's very useful, but again, it's mostly useful for sort of defining certain kinds of word relations, essentially. It was a thesaurus language taken to the web. So how many of you use SCOS in your systems or things? Everyone knows SCOS? Yeah, okay. I figured in this crowd I didn't have to spend much time on it. But again, the problem with SCOS when you're trying to link to other people's things is you may have same relationships, but very few people say, this thing in this area is SCOS same as or SCOS equivalent to something in this other place. So we're not using it for enough of the linking, which makes this integration and evolution hard. So, so there's some various things going on. So one of the things was, OWL was based on a model having to do primarily with inferencing and reasoning, right? I can go into the whole history of how that happened. I lived through it. I take some of the responsibility, and I apologize in advance and in retrospect. But again, the notion of how people would really be using this stuff was really driven more from the point of view of adding knowledge representation in the traditional AI sense to the linked data or to the semantics of the data, rather than primarily being about what we needed to do the data integration and the data operations. So I've given a number of talks. You can find there's a pointer to one, and these slides will be shared, that talks about some of the things that would be really useful here. So, you know, one of the things that drives everybody crazy, has been driving me crazy since the day we defined it, is the decision not to put part-whole relations into OWL. But in almost every useful case, one of the things you have to do is say two things, you know, this is part of something else. And the problem is there's about 3,000 years of philosophers fighting with each other, 2,000 of them actually fighting over it. The first 1,000, they were just trying to define things. And it has to do with whether it's transitive or not and things like that. So if I'm part of an organization, and if my hand is part of me, is my hand part of the organization, that kind of thing. And you can find, I mean, literally thousands of papers about it. So the group that was doing this, again, trying to maintain logical purity, just said, let's not go there. Okay? Turns out, though, that to do a lot of what you really need to do, you need that. And so almost every useful ontology starts by defining some kind of part whole. In fact, the gene ontology, which was one of the driving things, was sort of the gene ontology coming together with the open data and semantic web frameworks that really broke open a huge amount of ontology use in the health community, in the cancer genomics, et cetera, what became open biological ontologies. And their first relationship was part-whole. So they had synonym and part-whole were their main two things at the beginning. So you know, the argument that was being made in the original OWL committee was, well, let's just pick one and go with it, and we'll put somewhere in the literature something that says, and by the way, there's lots of other ways it's used, but people were too precise to allow that. We need to get that in, or things like that. In fact, one of the things I find very amusing is in OWL 2, when they added what's called quantified cardinality, something that I had fought very hard to keep out of OWL, the example they use is a precise way of saying if you have something, the equivalent of if you have a hand, it has 5 fingers, one of which is the thumb, right? But it has a precise way of talking about the 5 and the 1, and then it used 5 parts of your hand. But the part thing was not a standard relationship. It was one that has to be made up by everybody differently. So you lose the interoperability among the most important part of that. Procedural attachments are really important in a lot of worlds and a lot of work, and historically wasn't an OWL for the simple reason that a company had a patent on how to put procedural attachments on description languages. They weren't willing to release the patent. That patent has now expired. But a lot of what people do in the real world is, again, and it's particularly because this is metadata, I have something that says when you get this relationship, to find the instances, run this program, do this thing. Or if you want to know the relationship between A and B, you have a relationship called X, but the way you compute that relationship is by running some kind of system. Or it can be something as simple as I have feet in one database and meters in the other. Exceedingly hard in OWL to express that relation. Absolutely trivial if you have a procedure that says just multiply by this number, right? So again, it's a lot of things that really are heavily needed weren't there for reasons of purity, reasons of politics, reasons of ownership. So a real world standard inherits many of these things. RDF schema too, several things, same kind, and there's some other things too. So one of the things I've been arguing is we need to come back to some of those original ideas with a community that really wants to use this stuff and doesn't really care about logical purity, or at least doesn't care about logical purity being the only driving factor, and really cares more about usability, need, et cetera. So we've been doing this stuff for 20 years. We've been doing it exceedingly actively for 5 or 10, right? We now have large enough communities to start saying, okay, where is this relationship? Where is the thing that would let me put my linked data into collaboration with someone else's linked data because we have this kind of terminology we want to use? So that was really the main thing I want to do. Validate, actually, I had here a different slide, and unfortunately uploaded the wrong version this morning. So a lot of what we do in AI these days is coming from learning. And so you have these machine learning systems that have imprecise abilities. So they're learning quite well, they just don't get everything right. And again, the Michelangelo example was a really example. What can we do about that? And the answer is some of the semantics using some of the inferential capabilities can fix it. It can also, basically, you can take what's on a causal model and what's on a correlative model and put them together. So in the data analytics world, that's the more important one. But an example, the slide I actually wanted here is a slide from some work we did in open data for the US government from back in about 2008. We started releasing it by 2010. About 2011, 2012, we had thousands of databases from the US government online, the UK government, other governments started tracking. By 2013, we had actually tracked over 1 million open source database, open government databases around the world. There's even more now. A lot of them at the time were using RDF. Most of them, there are still tools to get at it, some sort of linked data format. If you want it, they've moved more to an API type thing, which maps to some linked data through various things. But we had taken a bunch of the US databases about forest fires and forest fire budgets, and we had put them together. And we discovered that in one particular year, I think it was something like 2006 or 1996, there was a 0 in all the categories, right? And it had never been noticed before because, you know, again, in any given year, there might be a forest fire in one state, but not in another state, or some budget might be grow or cut. But for it to be in every state in the union at the same time, in every case. So what happened is, it turns out they had done a database migration and had screwed up that year's data, right? So we found that the authoritative data being used by the US government to do much of its planning and things like that for many years, again, the local databases were fine, but they had this one glitch in them that you couldn't see till you put them together. So there was no integrity constraint that was violated by any one database. You had to put them together. Again, there's nothing wrong with the fact that there's a turtle named Michelangelo and a person named Michelangelo. The problem is when you put them together wrong. So how you put things together right and wrong can help you validate whether you're doing the right thing. So any human looking at that picture of Michelangelo, you all laughed when you saw it, right? The computer didn't laugh when it saw it. It doesn't know how to do that, right? It doesn't know how to say that's ridiculous, right? Turns out if you look at some of the stuff going on in machine learning today, you have some really, really powerful tools and some other things where a human looks at it and says, that's ridiculous, right? How do we start to at least human in the loop, and preferably with more automation and stuff, start to solve some of those problems? And then I'm going to end with just some stuff we're starting to play with now at my university to look at new ways of exploring based on some of this metadata. And now this is going to be really exciting for me because I have no idea which of the set of slides. Okay. So this is actually a device we've been playing a lot with collaborative and immersive visualization, and we've been doing it for data analytics and a lot of things. This is one device we have where people can sit around. We call it the campfire because you sort of sit around and look in and project on the floor and the walls. And then we have another thing with an immersive screen I'll show a little later. Okay, good. This is the long version. So we started setting out at one point to help use some of these visualization tools, playing with some data. And I wasn't involved in some of the early days, so the idea was to use sort of some game-based story telling and some limited language to basically create some kind of tour guide. I know it's too small to read, and that's okay, but basically it was about the Olympic Stadium. So the original version had about 500 topics that included the venues, the sports, the athletes, some of the special events and data. And they had a sort of ad hoc way of linking these together. So you could do something like this. So if you clicked on the Michael Phelps link, you'd get a description. So in there it says, you know, the Olympic Games, known as the game, blah, 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 took place in Beijing. And the user said, I remember watching the swimming, tell me about Michael Phelps. And the agent says, Michael Phelps is a competition swimmer and the most decorated Olympian of all time with a total of 22 medals. Phelps holds all-time records and blah, blah, blah. So it goes on and on about what happened, right? And some of the other things he's done. So in other words, what it's done is it's taken that information about Phelps and it's using it appropriately. So I started working with this group because we realized that what they had at the bottom was a bunch of connected entities, right, and some good heuristics for how to choose. So given you were at one, which one would you talk about next? And I said, wow, you know, we have these very, very large knowledge bases represented, these knowledge graphs, right, where we have lots of these kind of relationships, and we even know some of the semantics of meaning. So we started a project where we used information extraction, semantic web technologies, some AI computing technologies, and some storytelling technologies. You can see I'm purposely not telling you much about it, and that's just because it would take too long. I'm running out of time. But again, we use some of this stuff to abstract stuff from text, organize it into knowledge graphs, and then use some storytelling techniques on it. And we were able to do some really neat stuff with that. We have things that tell you about the history of various civilizations. So we would load it up from DBpedia, right? Just grab a bunch of terms. That would give us a first knowledge graph. We'd highlight certain kinds of relations as interesting. The system would do what were called storylines, which I don't fully understand how it did it, but it would say, you know, from this topic to this topic to this topic to this topic is an interesting arc. Then it would take those graphs of storylines and know where they branched or not. So basically, a user would be taken along to a certain point, and when it got to branching, would allow the user branching. So it looked a lot like a lot of the early ideas of what hypertext was all about, was to allow this kind of branching and exploring, but on a more organized thing. And I started thinking, you know, any place that has a lot of metadata tied to a lot of entities would be an interesting place to deploy this. So I went up to our university library and said, you know, I know you guys do a lot of collection management. What do you have there? And they had these XML pages describing, you know, all of the old photos of the university, and they included some information about where things were and what they were and who they were. And we had a lot of old documents, we had a lot of old images, we had a lot of the knowledge of people and things like that. So we actually started taking that knowledge, turning it into semantic web using fairly simple heuristics because they had already done most of the organization using James, and then putting it into this system. And I don't have a working demo of this at this point, but again, it sort of looks like this. So you're seeing simultaneously information about people, places and events and links between them. At the time we were doing this, we were using this setup to do some immersive work. So there's a map of sort of the area around the university, a timeline of what's going on, and over on the other side is something that would be showing you some of the famous people and places in the university. So this is something that, a project that I'm really excited by, although it's on hold at the moment for reasons simply that the people who are doing it are on sabbatical. But what I think is interesting about it is it says, you know, we've been doing all this work on linked data to sort of recreate a lot of capabilities we had in the old single collection world across collections. But we haven't really been looking at the fact that this very powerful metadata we create to be able to do these things also gives us new ways to access and change what we're thinking about. And I know a lot of people here have been playing with APIs and things like that to do exactly that. So again, so it's repurposing the semantic web stuff. It's the fact that you could link together these information from different parts of archives, different collections, different people's collections, over to something else. That really is what the semantic web vision was about at the beginning, right? So again, we've got a huge base of linked data out there, a lot of it linked open data. But to me, the really exciting thing is we also have this metadata potential around it that we're really not exploiting to the level we can. So to sort of finalize what I've been talking about, long-standing goal of the Semantic Web initiative was to create metadata, right? This was a key part of the original vision. More and more of what we've been doing, though, has been focusing on linking the data, building the knowledge graph, et cetera, and moving away from this enriched metadata concept, right? The term ontology became scary, and OWL2, a lot of people looked at OWL2 and said, thank God I knew that stuff couldn't possibly be usable. It's too hard to understand. So they moved off and did different things, right? I think that was helpful in some ways because people started actually thinking more about linked data and things like that, but moved them away from the semantic space. So I want to sort of see the world go back to some of that original semantic concepts, particularly with the focus on discovery, integration, as now I'm starting to say exploration. And to really use these metadata in new and exciting ways. And I think that's really where a lot of the interesting potential is now. How do we take, you know, what we have in that metadata and what we're getting out of machine learning systems and start to integrate them? How do we start to explore the metadata, et cetera? So before I finish, I'm just going to do the two things I mentioned. One is ask you all for a favor, which is that I've become recently the editor-in-chief of a new journal, and the last thing the world needs is a new journal. But this was really a journal that they came to me and said, you know, we want a journal that's really about open data, about data sharing. You know, there are whole communities that do this, right? Nature Science has a, you know, there's now Nature : I forget, data something. But they really are almost all focused on biology. Occasionally they have other fields, but it's all really on technical data, not so much on usable data from all sorts of fields. Two is it really is very little about this whole metadata stuff I've been talking about. So if you go to www.dataintelligencejournal.org or just search on Data Intelligence Journal, see it. But the other thing that I'm really excited by is what convinced me to get involved was this is a joint project now between the Chinese Academy of Science and the MIT Press with the purpose of exploring models that will better translate and I mean the term both as a pun and as not a pun, so translate language-wise, but also models that will work in the sort of Chinese world of information sharing and the US, UK, EU kind of approaches, which are very different. A lot of the same ideas, a lot of knowledge graph, but some things are more open, some things are less open. The journal is born open, so at least for now we are keeping it as open as possible. MIT Press wasn't willing to guarantee it would be free forever, so it may someday have author things, but if we can reach a certain level of substance, Chinese Academy has said they'll actually cover those fees. So we're still working out a lot of the deal. But really the idea is, actually, you know, part of what excites me is I was at a talk where it was somebody talking about citations around the world and showing that citations, that when you're collecting somebody's citations in language X, you may be completely missing all their citations in language Y, right? Unless someone has gone to the issue of doing the linking, which we have in the English-speaking world. In the Chinese-speaking world, they've done it among many Chinese dialects. So, you know, you may have a paper on linked open data that's being heavily cited in China, and you wouldn't know about it. Similarly, they might have a paper that's been translated and published openly, or not openly, in an English-speaking journal, and it's getting missed precisely because of the name metadata and things like that. It was really interesting. We were doing some comparisons of how bad, we're all aware of how badly current indexing schemes and things like that tend to do on Oriental names because of the lack of standardization of spelling stuff. We were being shown that the Chinese system has tremendous troubles on the European and English names, right? Partly, you know, we have the van and the de and the things like that in the middle of a name. In Europe, in the US, we have John, you know, we might have Jim, James, J.A., right? They don't have that same kind of abbreviation notion, so they were seeing as all separate people what were done. Obviously, unique identifiers would solve all these problems, but finding a unique identifier system that you can A, make work across the whole world, and B, retrofit to what's out there is very hard. So the journal's all about just thinking through some of those issues, which you can see is why I get excited. It's very related to what we actually have to do to make this stuff work. The other thing is, many of you have seen this book, Semantic Web for the Working Ontologist. A second edition came out a number of years ago. Didn't have a whole lot of linked open data stuff in it by name, but it was really about how to use linked open data. Dean Alamang and I were the authors. Now Fabian Gondin has joined us, and we're working on a third edition, which is well along the way. But what we really are interested in is, oh boy, that's really readable, green on green. Basically find my web page, and my email address is there, because I don't like to put my email address in things that are downloadable from the web directly. But we really welcome thoughts and comments on what has to be in the new book. What would be really useful to people, right? We're adding some JSON LD. We're talking, the subtitle will now include, so instead of saying effective modeling in RDF, S, and OWL, I believe the new title is effective modeling with linked data, RDF, and OWL, or something like that. So again, we're trying to really make sure we get a lot more of the linked data stuff in there. So I'll stop there to take questions and comments and things like that. Thank you.
Thank you, Jim. Any questions?
I'm a professor. If you don't ask me questions, I'm going to start asking you questions.
Yeah, I was wondering how it is that you, when you're looking across a big data set, how do you find what's interesting? So you were talking about the narrative. So out of all of your choices, how do you evaluate that?
Well, let me answer. I liked the question right until you got to that part about evaluate. So first of all, you know, a starting place is once the mechanisms are in place. I mean, if you think about it, when you use an app to access something, they've already made that decision for you. They've kind of built in what's useful. Many of those same heuristics and things work here. Valuation is a little more complicated. How do you decide if you're getting it right and things like that? And we've been grappling with that. But what we've recently been noticing is that there's really two different things people are trying to do in their kind of, so when you move away from search, saying, I'm looking for this entity, and move to what else can you do, you find that sometimes people are looking for what is most related to X, but other times they're looking for sort of what is interesting in the same sort of cloud of stuff as X, right? So I don't want you know, if I give it a search term and I said, but don't show me the most obvious results. If the system just returned random results, that would be bad, right? But if it would return interesting results by some definition that I can't give you, that would be really cool. So there's been some work on that, and we've been exploring some of that. And the biggest issue with that is sort of how do you evaluate? So I had a student who recently finished a PhD, is now working at a large German company, and working on very much the idea that, you know, how do we use pragmatics in this stuff? And so if I said to you something like, you know, has anyone here seen a picture today of a blue car, right? I emphasized the word blue, but even if I didn't, blue is clearly somehow must be important in that, right? Because if I didn't care what color the car is, I wouldn't have put the word blue in, right? Now, I might have said car versus truck, car versus a different entity, things like that. So if you look at some of these popularities and word things and things like that, you can actually see that you can vary this. But was the person really looking for, you know, a blue car, or were they looking for something else? Was the area, so if I said, did you see you know, so I'm looking at a police report, right? Has anyone seen a blue car of this type in, you know, in this town today? maybe if you'd seen a blue car of that type in a different town, that would be interesting, things like that. So how do you get both breadth and depth into this? And so it's easy to put in some parameters for that and to get some interesting things to happen. Question is, how do you really evaluate and tell in any formal sense that you're getting that right? And again, once you have the linked data structure, you can at least start putting some metrics in there, things like that. So we are playing a little bit with that. But I think the really interesting thing there is answering the question you asked first, which is how do we figure out what we're looking for, what else can be done, what are other things than just searching the metadata, and how do we encourage more of that? Yeah.
So, of course, I was interested in your reference to family names not necessarily being the same between a whole bunch of East Asian countries and Western. So for your journal, why don't you use identifiers so you don't have that issue?
So there's no problem with us putting identifiers in our journal, right? The problem is when you put citations in your paper, right? If you can find our identifiers, that would only be the ones.
Well,
so the problem is not that there aren't any schemes for identifiers. The problem is there's a lot of schemes for identifiers, right? So again, everything we do will have DOIs and various DOIs and various things like that. In fact, I spent a large part of my life fighting with Bob Kahn to make it so DOIs would be dereferenceable on the web. Right, because that way, I mean, and that's what we now use for a lot of our searches and things like that. But again, the problem isn't how to fix it for our own collection. The problem is how to link this. So if someone in China wants to cite the Semantic Web paper from Scientific American and cites it as a set of Chinese characters, right, even if my name appears, how do we know that that was the same paper?
So what identifiers are you using for authors' names for your journal?
We're actually at the moment still working on that. I believe we're going to use the MIT Press solution. The problem is they don't have a single solution at the moment.
Yeah, so that's why I'm asking, because you're just promulgating yet one more set of identifiers that need to be reconciled with all the other identifiers. So why don't you use...
So the only thing I will tell you is we promise to use something that someone else is also using. But what we can't guarantee is we're using what everyone else is using. But yeah, we don't want to make, again, there's a famous cartoon which says, the problem with the world is there are a dozen standards for X. And you say, let's go and get it right this time. And then you see a bunch of people standing around later saying, there are 13 for, standards. It's not an easy problem. There's a lot of people working on a lot of different persistent identifier schemes. The one thing we're committing to is we will have a persistent URI of some kind. So whatever identifier you're using, if you link back to that, you'll be able to find all the others that have linked to it, right? At least if we can discover them, right? And again, that's exactly the thing I've been talking about today. How do you make we're using X and you're using Y. If someone builds a mapping, that should map all of them, not one at a time. But in fact, we tend to do these one at a time solutions. I don't have any magical bullet for solving that, but I think, again, a lot of this metadata stuff would at least so when I do a search on someone's name and I get a bunch of people showing up, I usually add some other identifier. So I say, I'm looking for, we're doing some hiring now, so I got something and I want to check somebody's, Google Scholar rating. So if I type the name, I get a lot of people by that same name, even if they're all authorized names, right? Well, if I add some other things, then I start to find things. Yeah, keep them up to date. Oh, absolutely. And Denny Van Drasek has been beating me up on that too, so we'll be listening to Denny on this. Yes.
Okay, thank you again, Jim. Before we go into the coffee break, I want to let you know that the flip charts for the lightning talks are here. So if you want to hold a lightning talk in the afternoon, please put it up here, and so we know with how many talks we have to deal. And yeah, I think that's about it. Thanks again, Jim, and have a nice coffee break.